Here are some different normal distributions, and what we're seeing is that they all have different heights, like how high they are. And the mean is here at the middle for all four of them, but what we're seeing is that this distribution is more spread out. See how its purple bar goes much flatter and it goes way out to the left. Remember our measures of spread, our standard deviation, and our range? Well, in this case, what we're seeing is that the standard deviation is large compared to these other three distributions. And a larger standard deviation, we still have the same mean, but a larger standard deviation spreads our data out more and gives you more of the data going out to the ends than right here at the mean. That's a large standard deviation. For the green one, the light green one that's labeled C, that distribution is a little bit higher at the mean. Remember, the height is the same thing as a height in a histogram because that's where it comes from. And the height in the histogram tells you how many people had that mean as their measurement, their data measurement. And so when it's higher, that means more people are right there at your mean for this distribution, which means your data is more closely packed at the mean. And so C is starting to look like that. It has a higher peak here at the mean, and then it goes down on the outer edges, but it's still going to have a pretty large standard deviation because you can see it's really spread far. If we look at B, then we start to see it going down very fast and out to the ends. See how it's doing that? Going down very quickly and out to the ends. That's going to have a very small standard deviation because most of the data points in this data set that's represented by the distribution for B, most of those data points are right there at the mean. And you see that? They're not very far apart. So your one standard deviation will be here, 2 away, 3 away, like that. 1, 2, 3. And when you have data with a small standard deviation and it's kind of closely packed around your mean, you have the mean is a very good representative for that data. And the final one to look at is A, and you can see very, very steep sides, still really clustered around the mean, and goes down very sharply and spread out. So this one has the smallest standard deviation probably, and as you get higher in the alphabet, those have the larger standard deviations for sure. So the standard deviation, sigma for a population, will determine how spread out the data is. The standard deviation tells us how far an average piece of data is away from the mean. And we've talked about that before, but it never hurts to hear it again. The smaller the standard deviation, and this is where we want to kind of make a rule of thumb for ourselves, the smaller the standard deviation, the closer the data is packed to the mean. And in the picture, the mound will be higher in the distribution. Okay, and if you have a larger standard deviation, you have less data around the mean, and it's spread out more evenly towards the ends of the distribution, and that makes the mound shorter or lower right at the mean. So like right here, it's much shorter than this A curve, which has a higher amount of data right there packed at the mean. And here you have less data packed at the mean, more data spread towards the ends. So looking at these figures, I already told you which has the higher standard deviation. Curve D is going to have the higher standard deviation, and curve A has the lowest.